polygons. Polygons. So that's the topic we're looking at, polygons. So when we're looking at polygons, we're just looking at shapes with many sides. Okay, now almost any shape qualifies here. And the first thing we want to do is just to name shapes according to the number of sides that they have. So if I put a little table, number of sides, and then I put name on this side, right? So perhaps another color there. We'll start from 3. You can have a shape with one side. 4, 5, 6, 7, 8, 9, 10. Hope they fit. A shape with 3 sides is known as a triangle. A shape with 4 sides is known as a quadrilateral. A shape with 5 sides is known as a pentagon. A pentagon. A shape with 6 sides is known as a hexagon. So a hexagon. A shape with 7 sides is known as a heptagon. Heptagon. A shape with 8 sides is known as an octagon. A shape with 9 sides is a nonagon. Let me just squeeze the 10 sides is a decagon. So you have a triangle, a quadrilateral, a pentagon, a hexagon, a heptagon, an octagon, a nonagon, a decagon. Those are the shapes that you need to know by name. Now let's go further. Polygons can be known as regular. So you can have what is called a regular polygon. Now, what is a regular polygon? A regular polygon has 2 features. Number 1, all its sides are equal. So if it's a shape with equal sides, all its sides are equal, then it's a regular polygon. It also follows that all its angles will be equal. So a regular polygon has all sides equal, and it also has all angles equal. Now, if something is called irregular, right? If a polygon is now called irregular, it means the above is not applicable, right? This shape would not have equal sides and would not have equal angles. With that said, let's move to the part of interior angles. Let's look at interior angles of a polygon. Interior angles. The word interior means inside. So if I have a polygon like this, this is a pentagon, these angles that we're looking at, these are the interior angles of that polygon, right? 1, 2, 3, 4, 5. Now we have a theory that is there for those interior angles, right? Which I'm going to put in yellow. The theorem says the sum of angles, which is the interior angles, is equal to n minus 2 times 180 degrees. In this case, n is number of sides or angles. So sum of angles is equal to n minus 2 times 180. So for a triangle, n is 3. For a quadrilateral, n is 4. For a pentagon, n is 5. For a hexagon, n is 6. For a heptagon, n is 7. For an octagon, n is 8, and so on and so forth. N represents the number of sides. So the total that I get after adding up all the angles of a particular polygon depends on the number of sides or the number of angles that it has. Now let's have an example to show the practical use of this theorem, right? So example, a regular hexagon, right, has one of its interior angles measured. How big is the angle? How big is the angle? Now, first things first, we need to understand one thing. This thing is regular, number one. Number two, it's a hexagon. When it's regular, it means all sides are equal. When it's a hexagon, it means the number of sides, n, is equal to 6, because a hexagon has 6 sides. So we can simply plug in our formula. Our formula says sum of angles is equal to n minus 2 times 180. So sum of angles will be equal to 6 minus 2 times 180, which is 4 times 180, which is 720 degrees. So if I were to add up all the angles of a hexagon, I get 720 degrees. But we're not done yet. This thing is regular, meaning that all angles are equal. So it's regular and it has 6 angles. So to find the size of each angle, we take the total 720 and divide by 6, because 720 is the total of 6 angles. So we know that each angle will be equal to the total 720 divided by 6, which gives 120 degrees. So the size of the angle that was measured was 120 degrees, because for a regular hexagon, all angles are 120 degrees. Okay, so let's proceed to another example, right? E.g., so we've got 90 degrees, got 150, we've got 110, then we've got x, then we've got let me say 60 there, 160, and then we have 2x. And then you're asked to find x. So here's a shape here, and you are asked to find x there. So again, we have to find n. 1, 2, 3, 4, 5. This thing has 5 angles, so n is equal to 5. So we can immediately plug that into our formula. Sum of angles is equal to 5 minus 2 times 180 degrees, which is equal to 3 times 180 degrees. And if you multiply that, that gives you 540. So that's a 540 degrees. So if I add up all angles, they should give me 540. Meaning if I add this, and this, I should get 540. So that's x plus 2x plus 90 plus 160 plus 110. Okay, that's what we need to put on the other side. So x plus 2x plus 90 plus 160 plus 110 is equal to 540 degrees. So that gives you 3x. If I add this up, plus 360 is going to be 540. To solve the equation, I take the 360 the other side. It becomes a negative. So 3x is equal to 540 minus 360, right? That's going to give us 180, right? So 3x will be equal to 180 degrees. We divide both sides by 3 to cancel off that 3. Then I'll get x is equal to 60 degrees. So that's how we deal with the angles, interior angle questions. So you'll try some questions on interior angles.